Hello, everyone. Welcome to today's InfoQ live roundtable webinar titled AI Agents and LLMs Scaling the Next Wave of Automation. In this webinar, we will discuss the latest advancements in large language models or LLMs and the recent trend of AI agents and agentic AI architectures. I am Srini Penchkala. I serve as the lead editor for the AI, ML, and data engineering community at the InfoQ.com website. I will be facilitating the conversation today. So this webinar is being recorded and will be published on the InfoQ website at a later time. So for you today, we have an excellent panel with subject matter experts and practitioners from different specializations and organizations in the AI and ML space. Our panelists are Hian Liu from Zoox, Karthik Ramgopal from LinkedIn, and Govind Kantamneni from Microsoft. Thank you all for joining the discussion today and sharing your experience and thoughts with the audience. Before we start the main discussion, to our audience, we want this to be an interactive conversation. So please post any questions you have during the webinar in the chat window or the questions window. I'm not sure which one is accessible easily, but you can use either one. Hopefully, chat won't be too won't have too many messages where the questions will probably go too fast. So, and I will bring up these questions during the discussion or at the end. Hopefully, we'll have enough time for all the questions. So let's get started. We will start with the panelist introductions. Hi, Ian. Would you like to introduce yourself and tell our audience what you've been working on?
Yeah, I'm more than happy to. So, good morning, everybody, or good afternoon or evening, depending where you are. My name is Hing Liu. I currently work at Zoox. We are in the autonomy space. I lead the ML platform team there. And I've been working on the ML infrastructure area for many, many years now. One of the my hobbies is teaching, so I've been teaching at like an extension school in the areas of generative AI. So it's been really, really fun. Um, Yeah, I just want to say that, right now it's a very exciting time, right? Everybody knows we're in the midst of an AI revolution. So much innovation, advancements going on at the moment. So it's really, really fun. And yeah, happy to be part of this Agentic AI roundtable.
Thanks, Ian. Govind, thank you for joining us. Can you please introduce yourself?
Yeah, absolutely. Hello, everyone. Thanks for making it here. And I'm part of our global black belt team, basically an extension of engineering here. I'm a technical director here, and I work with close to 200 customers since we launched this Azure OpenAI service. It's obviously been, as Ian noted, a revolution. Every experience and application is being evolved, to be AI native, whatever. Essentially, personalize or automate parts of your workflows or your experiences. So yeah, there's a lot that we'll discuss here. There's a lot of things that customers are, things that are working for customers, but also not working. And I would also love to hear from you all, if you don't mind reaching out on LinkedIn, even sending a message as to, how you're leveraging AI, Gen AI specifically, and, what's working, what's not working. It'll be great to connect as well. Thanks.
Thank you. And Karthik, how about you?
Hey everyone, so my name is Karthik Ramgopal. I'm a distinguished engineer at LinkedIn. I'm the tech lead of our product engineering team, which is responsible for all of our member and enterprise facing products. And I'm also the overall tech lead for all of our generative AI initiatives, platform and product, as well as increasingly internal productivity use cases as well. As everyone said, a huge revolution is going on right now. In my opinion, after the Industrial Revolution, this is going to be the biggest transformation we're going to see of society in general. But as with anything else, there is a lot of advancement, but also a lot of hype and noise. And what I'm hoping we will see through the panel today is how to cut through some of that and focus on real world insights and examples of what you can actually do and what you will be able to do in the future potentially with these technologies.
Thank you, Karthik. As I always say, definitely we want to highlight the AI innovations that our audience should be hyped about, and not the hype of the AI innovations, right? So definitely welcome everyone. We are looking forward to speaking with you on these topics. So Ian, maybe we can start with you. There are so many different definitions and claims about agentic AI solutions. To set a common base of understanding for this discussion and for this forum, can you define what's an AI agent and how AI agent-based applications are different from traditional AI applications that have some type of a job scheduler, a workflow, and a decision-making capability built in, right? So how is this different from those other apps?
Wow. Okay. Those big questions there, but it's good to establish some kind of a baseline. I'm gonna give my best shot here and love to get thoughts from the other panelists as well. Yeah, initially when I learned about AI agents, probably about a year-ish ago from Angeline, introduced that, I got really confused. Like, what does it mean? And the term, it's hard to digest in terms of what it encompasses and stuff like that. So for me, the way after like reading a lot of blog, learning, whatever, the thing that really helped me understand is really step back and really understand the term, what is agentic or the agentic part of AI really, really means in terms of its own definition. And I look it up, and according to the dictionary, it says like the ability to act independently and achieve outcomes through self-directed actions. And I think when I read that and I map that to, there's a lot of discussion about what AI agent systems are, it's starting to make a lot of sense. So hopefully that makes it a little bit easier for other folks that are um, a little bit confused about what this AI agents are. So with that, right now we map it to what AI agents are. So essentially, like these are applications or systems. They're designed to solve certain complex tasks or they have certain specific goals. They all typically centers around like one or LLMs. LLMs now is extremely smart, so they are used to help with reasonings, plannings, and now that tool use are a part of our tool sets now in terms of building LLMs applications. So these application systems where they use these tools, they can plan, they can reason, they can interact with environments, and they maintain control how these systems accomplish tasks, essentially. So that's where the agentic part comes in, of using the smart LLMs now that can reason and plan. So that's kind of my way of interpreting what this means. I think the three concepts that I learned that's helped with understanding is just the autonomy aspect of it. This is one aspect that's different than your, classical AI ML systems, where they're designed to solve specific tasks and stuff like that. So the autonomy to figure out what are the steps to solve the problems. The second one is the adaptability, that they now can reason and plan, they can adapt the steps based on the tools that they use in the active environment. I think the last one is the goal orientation. I think it's another part of these AI agent systems. I'll end with this one statement or definition that I saw, which I really like in simple terms, is an AI system with using LMs in a loop. You might have heard that before. But I want to comment one more thing, though. I'll share back to the panels here. So entering this say something like, instead of arguing over what the definition's like, we can acknowledge that there are actually the different degrees of being agentic into systems. So yeah, so I'll stop here and
Yeah,
we'll love to hear thoughts from other panelists as well.
that's good. Thanks, Ian. So Karthik, maybe you can chime into this question from Anidya, right? One of the attendees.
Yeah.
So I think I had a similar clarification question, right? So AI agents versus agentic AI. These two terminologies, how do we define those?
Yeah, so I actually like replied briefly, but I'll respond right. Agentic AI refers to the entire system. If you look at the system, it comprises of AI agents but it also comprises of orchestrators to orchestrate across these AI agents. It comprises of tools which you call in order to interact with the real world to do something. And again, systems for coordinating with these tools like MCP, which we'll get into a bit later in this discussion. Like you also have like registries of like various kinds to announce things, to access things, etc. So that end-to-end system is what is called as an agentic AI system, and an agent is just one small component of this system.
Thank you. Govind, would you like to add anything to?
Yeah, I think that's well put. In fact, Berkeley has been coining this term compound AI system for products that we're going to ship eventually, because there will be aspects of a workflow that requires agency. For example, like when you're, let's say you have an email automation system, right, that automates, intake. That basically, I'm actually working with this customer who's doing this at scale. Let's say you send a tracking number, right? It automatically replies back what it's doing there. Now, there's part of that where, of course, it has to access tools, but then when it drafts that email and sends it to the end user, it'll obviously factor in the tool's response, but it could also, this is where the LLMs, sort of stochasticity kind of comes into play. It can personalize the response. Maybe the reader or the person that sent the request, based on their, let's say, maybe reading comprehension, it could adjust the response to be more terse, short or lengthy, etc. So I think you can have workflows that are more predefined. Obviously, we have those business process automation for the last 20 years. We've been doing that, but you can introduce agency within the steps within the workflow. And as Karthik and Hian kind of mentioned, when you and it's a spectrum, right? You can have, like, there are some SWE agents, we'll probably get to this later, software engineering agents that can be more goal oriented, that can have a lot more agency to how they create that orchestration and create that code paths autonomously. So yeah, it is definitely a spectrum, but the gist of it is, like, use the LLM as in the control flow. Depending on if you use the LLM to drive more of the control flow, then it becomes a lot more agentic, which means it also introduces a lot more uncertainty. Let's put it that way. But if you can put it on Rails, and you can have more control over the code path and the control flow, that makes it more of a workflow with some agency. So I'll stop there, but yeah.
Yeah, I think one key difference with the earlier systems is what Govind was alluding to, right? Which is the emerging ability of these systems to autonomously learn and generate tools often to solve the problem, right? So it's called as, like metacognition, which is learning how to learn. This is still an emergent ability, but we are seeing in some of these cases, these agents are able to author snippets of code or are able to orchestrate across tools, for example, to unblock themselves to solve a particular task. Again, it sometimes goes off the rails, sometimes these agents get stuck. So these are still very like nascent capabilities, but that is a key difference from the systems of yore, where the level of agency, the level of cognition, and hence the level of autonomy enabled is significantly higher.
Yeah, that's a good segue to the next question, Karthik. Maybe we can stay with you on this. So agentic AI architectures are new and still evolving. Like you mentioned, they will have to go through some growing pains before they become more valuable than the biases and like hallucinations, which we'll talk more later in the discussion. But just kind of staying at the use case level. So what are some use cases or applications that you are seeing where AI agents are a really good fit? And also the other side of that question is, what are the use cases where AI agents and agentic AI solutions are either overkill or are not recommended, for the applications?
Sure. So I think any sort of knowledge work automation is where AI agents are excelling right now. I think it's only going to be a matter of time before somebody hooks up an AI model to a set of, to a set of actuators to interact with the real world, and they can do physical tasks as well. At least I haven't heard of anything happening at scale so far like that. So right now it's mostly limited to these forms of knowledge work, anything which involves a computer, anything which involves software, anything which involves calling an API, and anything which involves orchestrating a bunch of different things to make it happen, right? So that is what it's pretty good at. Now, what are some of the impediments there? The first impediment is that it goes off the rail and quality suffers. The second is that the evaluation of whether it is doing the job correctly or not is hard. And the third is, even with all the cost reductions, etc., these models are still incredibly expensive, and GPU capacity is fairly constrained at scale on account of a variety of factors. So there are some organic limitations in terms of cost, in terms of compute availability, and in some cases in terms of latency, which are also inhibiting crazy adoption, right? Now, where are they not good? Obviously, if you have any sort of like workflow where you want to have a lot of tight control and you do not want agency, effectively you're following algorithmic business logic. AI agents are overkill. They're going to be expensive and like they're also unnecessary. But one thing which you can still do is you can always use AI in order to help you generate that logic or generate that code beforehand before you deploy it. So it's like moving it further left in the chain, right? Like you do it at build time instead of doing it at runtime, and you still have a human verify it before you go and, sort of deploy it.
There is a question that probably we can ask this question in this context, right? So a question from Mike is how reliable does an agentic AI system need to be in order to be useful? So for example, 90% accuracy sounds pretty good, but picking up the pieces after 10% wrong results sounds like a lot of work, right? So like, I mean, again, where are we right now and where are we going with the anyone? I don't know who wants to take it,
Yeah,
but
sure. Maybe I can take a first stab at it. So that's actually a good question, right? And obviously, the classical answer is it depends. Depends on your use case,
Yeah.
and your risk appetite. I have some digital native customers who are pushing the frontier. Think of, for example, one of the I mean, not Gen AI, but traditional ML systems, since Ian is here. Tesla, for example, pushes the frontier and issues software updates for all kinds of FSD sort of things. And like I was actually experiencing FSD, and it's getting better and better, but there are those 10% cases where it does go off the rails. Yeah. But as a brand, Tesla is fine taking that risk on. So I think it depends on the experience you want to provide to the end user. Obviously, we're all here to serve their needs at the end of the day. And if you think your end user, wants the latest and greatest, if you can kind of caveat that experience by saying, hey, like, even when ChatGPT launched, I think even now on the bottom it says responses might be inaccurate or something like that. Just keep in mind that it will have implications to your brand and the sort of like the trust, right? So you don't want to tolerate too much risk or push that risk onto the end user. So yeah, just some initial takes, but I would love to hear he and Karthik.
Yeah, I think like most new technology, there's a certain amount of learnings and there's a certain amount of risks. Technology will get better and better. I think it's basically a journey for all of us to be on and learn and so you want to be smart about how to apply in certain use cases that are the consequence of a wrong decision is not too bad. So we can learn from that experience and then build on top of that and apply to more and more complex use cases in the future. So yeah, that's the current state of where we are. But there's definitely a lot of use cases where AI or genetic AI can be really, really tremendous. Like we saw with the deep research, right? That kind of use case is tremendous in terms of the ability to save time to do research. So
I think it's really hard if you talk about these quality percentages as a whole, because most of the use cases where AI is applied today, the product is fairly complex. If it weren't, why would you use AI, right? You just code it up. It's important to talk about components of the system and your level of risk tolerance in each of these components, right? There's also this concept of building confidence models and invoking human in the loop. At least with the capabilities of AI systems right now, doing full autonomy is mostly like a pipe dream, except for very few use cases. Human in the loop and a lot of AI system architectures need to be designed for this, because humans, you cannot put SLAs on humans, you can put SLAs on systems, where you actively invoke the human to ask for clarification or to ask for approval or to ask for input before you undertake a sensitive action. That is again a pattern which you can, like fundamentally integrate. It's also important to note that you have to be very careful with the definition of quality and correctness if you're doing tasks in a loop or if you're doing tasks in a chain. Because what happens is that if you have 90% accuracy everywhere, the error rates build up. First, it'll be 90%, then it'll be 81%, so on and so forth. So progressively, it could result in a much worse error rate than what you anticipated at the beginning.
That's a good point, Karthik. Also, on the other hand, right? So we can use these solutions to iteratively train and learn. Like you said, they can learn about learning, right? So that also you can use that to your advantage.
Yeah, it's very important to mirror the real world in the way you design these applications. I can give you a classic example, right? Coding agents. How do coding agents correct themselves? Well, just like humans do. You feed them the compiler error and then they look at it and then they know, oops, here is where I messed up, right? But without that integration with the tool which provides them access to the compiler error, they are equally in the dark, just like you would be if you aren't seeing error log show up in your CI/CD system.
Sense? Govind, did you have a comment or?
Oh, I was just gonna add to that. Yeah, 100% agree. And we do see a lot of systems like Cognition's Devin, for example, does a good job. And even some of the coding agents, when they're misaligned, it does ask for the human to provide clarification. And sometimes they also reward hack. So as a human, you have to validate the response that it generated. For example, some of these software engineering agents, they will accomplish your acceptance criteria, but then they might have hard coded parts of it. So we see that as well. So yeah, just obviously, humans are very much in the loop. They're we just have to work with them at a much more higher level abstraction, and the end result is output per human goes up, but human is very much in the loop. Yeah.
Yeah, and definitely I want to get into those couple of those topics a little bit later. So let's kind of talk about the technical details of these architectures, right? Uh, maybe let me see who is the best person. Oh, maybe Govind, you can probably lead on this one. So what are the agentic AI application architectures comprise of? So what are the key components, and then how do they interact with each other? In other words, what additional tools and infrastructure do we need to develop and deploy these applications?
Yeah, absolutely. I actually have a huge blog post about this with decision tree and all that. You could probably search my name and search for how to build AI agents fast. But essentially, it almost as similar as building earlier, microservices that are cloud native that we built. You need an orchestration layer or component that then obviously the model is doing the reasoning. So you need to have round trips with the model. And you need to, the most important thing with all AI agents and with the round trips with the model is the context. Ultimately, like, you're going to be spending most of your time on organizing that information layer and the information retrieval sort of aspect. So providing the right context is literally everything. So that layer is also very important. And there's the ways you organize information it can be more semantic. So there's a lot of vector databases. Pretty much every database now supports vector index capabilities, and that just allows you to improve the quality of your retrieval. And then you can of course stitch them together, as Karthik was saying, but be careful when you have too many multi-agents that are interacting with each other. Their rate can compound. But more importantly, the quality attributes of the system, right? At the end of the day, if you want reliable, highly available sort of systems, you got to make sure that there's a gateway in front of your system that handles authentication, authorization for agents as well. There's entitlements are very important for agents. You'll see a lot of the identity providers, including from Microsoft, we have Enter ID, kind of move in this space where we're going to facilitate agents to have their own identities, because we do envision a world where, on behalf of flow, there are a lot of flows with agents accessing data or tools is on behalf of user flows. We do envision a world where agents are going to be more event driven. They're going to act independently, and they'll then ask the human or someone for permissions, etc. So in that case, entitlements is very important. That's more kind of coming soon, but for now, just making sure that you have proper fine-grained authorization, etc. For the resources that the agents are going to access, or the orchestration layer is going to access. And then even between the orchestration and the model layer, you need to have proper, like usually we recommend some kind of L7 gateway that can handle sort of failovers or things of that nature, because these models ultimately they're doing a lot of matrix multiplications, and they're very much introduce latency to the experience. They are not super reliable. There's a lot of capacity problems, so you want to handle that scenario at scale. And then just packaging up like you would package any microservice and deploying it to any container-based solution. That's all the same. I think the one most important thing here is evals. So evaluations are key. Obviously the models are saturating a lot of benchmarks that are that showcase reasoning. Yes, they're highly good polymaths that can reason well, but the evals that you care about are, at the end of the day, whatever experience you're stitching, like create a benchmark for that, create evaluations that are idiosyncratic for your use case, and then and then there's a lot of libraries. We have one from Azure AI, but there's libraries out there on evals. There's Raygus, etc. Use those eval libraries and also do continuous monitoring and make sure you collect user feedback. And that data is also very rich, potentially if you ever want to fine tune and things like that. Make sure to store that data. So yeah, I mean, there's a lot there, but that's it's like the existing ways of doing cloud native 12-factor apps still apply, but then there's all these nuances with Gen AI stuff. I want to hear others as well.
That's very true. And I mean, what you said there, a lot of people tend to focus on those. Okay, what are the new ways of building systems, these AI systems? But similar to how we thought about building classical AI ML system, right? Where you saw that famous picture where AI, the model is just a small piece of the overall bigger system. And AI system is in a similar way, a lot of pieces that we learned over the last 20, 30 years of building microservices, all that's still applicable, and AI or part is still just a small part of the overall system. But there are some new parts like Govin mentioned that's very specific to the nature of these stochastic systems with evaluations and all that stuff like that. So I'm sure
Yeah, I'm
Karthik
glad.
got some thoughts on
So
this.
I think the other piece I would add is, see, I mean, the rules never change, right? Good systems design is still good systems design. I
Yeah.
would say account for the increased level of non-determinism in these systems, and that results in a variety of ways, right? First is observability. A lot of these stochastic systems we have for observability don't work here. You do not have predefined paths. By definition, there is a lot of agency and there is a lot of, you know, possibilities and various paths which can be taken. So you need to invest in an observability solution which will give you intelligible data from what's happening in production in the system. That's the first. The second is from a hardware resource capacity planning perspective as well, that this sort of non-determinism gets in, right? Like, hey, have you provisioned enough resources, or do you have enough safeguards built into your system to be able to throttle workloads, to be able to, asynchronously execute them when capacity is available, prioritize them appropriately. Again, these problems happen at a certain amount of scale, right? That's important. And I think the third thing is a lot of these systems, in addition to being slow, also fail because you have so many moving components, you have so much non-determinism, so you may not get the right output every time. So how robust is your error handling, graceful degradation, escalation to human in the loop, uh, all these things? And these are not just systems design, like they have to reflect every way from your UI to your AI, right? Because some of these also manifest themselves in the UI as to how do you respond to users. So that end-to-end picture is super important.
Yeah, I'm glad you all mentioned these additional topics that we need to be kind of cognizant about, right, in terms of AI context, authentication, authorization, API gateway routing, circuit breaker, observability. Karthik, you mentioned that. So I think I was kind of envisioning we would be talking about these more like next year, once like a phase two of AI agents. But I'm glad that that we're all talking about them now because these should not be afterthoughts, right? They should be built into the systems, right from the beginning. There is a question on the accuracy. Maybe we can um, kind of table that for the next topic. No, we'll come back to the accuracy and hallucination and all that, right? But before we go there, any other comments on the architecture side? Otherwise, we can jump into the software agents that I think somebody mentioned. Probably go inside. So maybe Karthik, you can kind of lead this topic. So most of our audience are senior technical leaders in their organizations. So they would like to know how they can benefit from AI agents in their day-to-day work tasks, which is basically software development and so on. So how can we leverage AI agents in different parts of the SDLC process? Like what is the new role of a software developer with more and more development tasks being managed by AI programs? Like you said, how can we be still relevant and not necessarily fear about AI agents, but embrace them and use them to kind of better ourselves?
I think what you said is at the last is very important, right? You should not embrace it. I mean, you should not fear it. You should embrace it, right? And see how you can use it best. So I can talk a bit about how I use AI in my day-to-day development. The first is I don't vibe code. There is so much hype about vibe coding. I still don't believe in the hype. It may be good for prototyping small things, but building anything serious, which is what I think developers end up doing in professional environments, not so great yet. Maybe it will get there. So what I do use though is I use a bunch of these AI native IDEs. LinkedIn is part of the Microsoft family, so we use GitHub Copilot quite a bit, and GitHub Copilot is getting better of late with agent mode and all these things, especially in VS Code. So again, I use GitHub Copilot quite a bit to understand the code base, ask it questions, which I'd have to research manually normally, as well as ask it to make changes, but it still makes mistakes, although it's getting better. So the onus is still on me to have a understanding of first, how do I use the tool? How do I prompt it the best? How do I ask the follow-up questions in the right way? What model do I choose? Right, because you have the reasoning models, you have the regular generative models which are non-reasoning for certain kind of tasks. Certain models are good. Again, you get to know some of these things as you start interacting with these tools more and more. And the second is, how do I review the output it produces? One of the challenges I'm facing honestly already is that AI is a great productivity accelerator, but it can produce reams and volumes of code way faster than a human can. So I need to keep up with the ability to review it because it can still make mistakes. And more importantly, the mistakes it makes are often very subtle in nature. It's not very obvious. So you have to have an extra eye for detail. And if anything, your conceptual like knowledge, as well as your you know, general ability to understand large pieces of information and synthesize results from it needs to get like better in order for, all of you to keep up, all of us to keep up, honestly, in this new world. So that is one area, right? Coding assistance and things like that. You can also use it for unit test generation of various kinds, so you don't need to write pesky tests yourself, although they are still very important for quality. Then there are also aspects of using AI for the right, where you can use it in order to understand anomalies in your traffic patterns, incident root causing, uh, you know, deployment failures, debugging issues there, etc. Right? So that is one entire category of things. Now you can also move further left, right, where even during the design process, you can use AI quite a bit. For example, we have integrated Glean at LinkedIn, and I end up using Glean quite a bit because it's connected to our entire corpus of documents, Office 365, Google Docs, our internal wikis, etc., which contain a ton of information. So if I'm doing some research, for example, to write a design doc, I will start with a Glean chat prompt, which essentially saves a bunch of grunt work for me from from going finding that information, putting references appropriately, and crafting the design. And again, that initial outline which is produced, I will refine it later with my human intelligence, in order to get it into the final shape.
Good. Thanks, Karthik. Govind, here, what other parts of the SDLC are you guys seeing that AI agents are being used?
Yeah, go
Add my 2 cents. Sorry, Gavin. I think testing is an area that these models can help quite a bit. I mean, most software engineers probably don't like that much writing tests. I think that's an area that we can leverage these tools to help with that. Not just writing tests, but also like asking, insightful questions about edge cases or kind of other things that Karthik brought up. So I would love to use that. But I think stepping back though, I think if I were, I mean, I don't code as much anymore, but if I were an engineer and I do that's my 100% of my daily tasks, I would like probably give more thought about like what kinds of question, because these LMs are there to answer our questions, right? If we can come up with smart, intelligent questions that are relevant to help our software engineering tasks, I think I would spend a lot more time thinking about what kind of question I should ask them such that I can improve whatever task I'm doing, whether it's that improving the robustness of the microservice or handling, throttling or whatever that is. So I think it's like, I think that's a different mindset, and a mindset that software engineering needs to start building more of like how to think about what kind of thoughtful questions that would be useful for their task. So
Yeah, 100%. I just want to add that the answers are all there, right? It's about like the questions that we ask and how we ask that matters. And what I'm doing a lot is I'm actually reading a lot. I'm actually having we have GitHub Copilot obviously has this developer inner loop experience, but there's also an outer loop experience that's going to be publicly announced next month called Padawan. And it's similar to Cognition's Devin, and there are others out there that do that. But what I'm using is to have it generate like so it's kind of like a deep research of your code base when you go to a new code base, and have it like generate mermaid diagrams and stuff, and really have a systems thinking approach to literally I'm using my Kindle a lot more now because I'm like reading and understanding what Ian and Karthik are saying, like so that I can ask the better question and pass the context that is needed to solve the very like focused problem or a use case that needs to be implemented. Yeah, so I do think like it will be. We're also going to launch SRE agent, and there's a bunch of these agentic experiences that will augment you, but at the same time, the onus is on the human to ultimately. Again, I think it all goes back to ask the right question because the answers are all there. I mean, look, these models like O3 high reasoning, it is. If you think about just the benchmarks, like you are interacting with a polymath that is the smartest, like one of the smartest coder out there, right? Like they're saturating all kinds of coding benchmarks, and it's only going to get better. So ultimately, it's up to you to know that user need that you're solving and mapping it throughout the SDLC process and leveraging these models throughout the process.
Yeah,
So I want
definitely.
to
I'm
give a
interested
very
in the.
crude example. I mean, a very crude example, right? When IDs came about, we saw a transformation in the development process, right? With respect to how people were coding inside the text editors. You had the ability to do structured find and replace. You had the ability to open files side by side. You had syntax highlighting. Developer productivity went up so much, right? You had debugging within the IDE, etc. Right? So this is similar. It's just an additional tool which gives you even more power over your code. But I would say don't look only at code. Code is an important critical aspect of the SDLC, but there are a lot of other aspects also, and there are AI tools which help you automate end to end, as Govind and Hian pointed out.
I
Yeah,
think
I'm definitely
Sam.
interested in the.
Oh, sorry.
Yeah.
I was
Go
just going to add one quote by Sam Altman. I think it's really catchy. It's like, don't be a collector of facts, be a connector of dots. I thought that was
Okay, good one.
Nice. The facts can be relative, right? So no, I agree with you. Also, I'm definitely more interested in the shift left side of the SDLC process. Like I mean, automatically writing tests for the code is important, but I mean, how much of that code is really relevant to your requirements, to really relevant to your design, right? So again, I mean, we can use AI agents to solve the problems the right way, and also we can use them to solve the right problems, right? So I think it kind of goes both ways. Yeah, definitely great discussion. Thank you. And Govind, I'm looking forward to all those different products you mentioned about. Padawan sounds like a Star Trek, connection there, right? So for the outer loop experience. Yeah, we do have one question, so let's get into that, right? Here, you probably a good person to kind of start this discussion is one thing we've been concerned about AI programs in general is the accuracy of their output because they are kind of have their own the concerns, right? So the accuracy of the output and the hallucinations. So now we bring in the AI agents into the mix and automate as many tasks as possible. Try to let the agents do what humans have been doing. So, like, how do you see this whole accuracy and the hallucination and biases, kind of, a space, kind of, transforming, I guess, with the agents? I mean,
Yeah, that's
how worse will it get, right? So,
it's the short answer is facts of life, so we have to deal with that. That there's no well, these uncertainty comes to us since day one of building AI system already, right? They all these undeterministics. They give you probabilities of an answer of a prediction, whether it's spam or not spam. So there's a measure that we've been taking, but it's more exaggerated with the hallucination, the natural language aspect of it's still more challenging than the numeric value. So definitely it's a challenge, and a lot of enterprises are concerned if they want to apply this into their real world use cases that where the consequences are not just content generation, but it can impact their user or whatever that's causing damages. So definitely a big concern for enterprises. I think there's studies after study why enterprises are way behind in terms of adopting these technologies. At a high level, I mean, in general, I think these LLMs are getting smarter and smarter. These AI frontier labs, they spend a lot of effort in improving or reducing hallucination, but nevertheless, there's still that. So the question is, what can we do with build these agentic systems? Like most things, we should start with at first to understand where this for your particular use case or use cases where the hallucinations, what's the cause of those might be. If you're building like a very domain specific kind of agentic system and using the models, and maybe those models were not trained with your domain specific area, that may be an indication that you might have to do something with that in terms of the knowledge cutoff or the limited of it. So understanding what the underlying causes might be for your use cases, the first thing to do. In terms of like what actions or methods or strategy that you can employ, I think there's a good sets of good practices that are out there now. Start with like grounding. I think it's a very common techniques now with grounding in terms of the context, go back to Gov and said, it's all about the context, right? So grounding the relevant information and stuff like that. That's why RAG has become very, very popular because of the ability to ground with relevant, content in the prompt and context. And this is something that a lot of people don't spend a whole lot of effort in. It's really, at the end of the day, it's like we're interacting with LLMs through prompting. And what we say in the prompt matters, right? So well-crafted prompt engineering is still extremely valuable and relevant to help with these kind of challenges. So be specific, all the other stuff that good prompt engineering practices. Other things you can do outside of that is like the guardrails we talked about earlier that people mentioned, and human in loop too, right? That's another aspect that you can build into your system of at proper time to involve the human when the response seems suspicious and doesn't pass the smell check kind of thing. So yeah, and then evaluation. I think that's it's all out there now. I think it's like people doing it or not. That's a different question. But building evaluation is requires a lot of upfront investments. And I think you want to do that iteratively and incrementally as well. It's not something that you probably can come up with a whole set that you've done. So it's something that needs to be dealt with in an incremental manner. At the end of the day, there's like techniques to help with reducing, but eliminating, I think we're not there yet, as far as my understanding goes. But I'd love to hear from an experience from Government and Karthik, who actually working with our customers and building actual AI agentic systems at LinkedIn.
Yeah,
Okay,
Karthik,
so I can
Karthik, go
share some of the other techniques which we use. The first is this technique called as critique loops, where effectively you have another observer critique the response, right, using the outcomes, right, and see if it meets the smell test of those outcomes. Now, again, this is a technique you use in evals as well. At runtime, though, you cannot use this very heavily. You cannot put a powerful model. You cannot have a very, complex critique logic because, again, it's going to consume compute cycles and latency. And there's always this trade-off between quality and latency and compute costs, etc. But in your offline evals, you can actually put a more powerful model, right, in order for you to actually evaluate the responses of your system and understand where it failed. I think there was a question in the chat about, hey, how do I do like evaluation? Should I do random sampling? Well, random sampling is a good starter, but I would say it first starts with the definition of accuracy. Do you have an objective definition of what being accurate means, which is actually quite hard in these non-deterministic systems to get a comprehensive definition of that. Once you have that, then you can decide how to pick and choose, because ideally you do not want to do random. You want to get uh, like a representative variation of responses and ensure that you did well across them. And again, that requires some sort of analysis of your data itself. Something which a lot of folks do is they capture traces, and of course they anonymize these traces to ensure that personal information is not emitted in whatever way possible. And after that, they feed these traces offline to their more powerful model, which then runs the eval and tries to figure out what to do. Uh, the other interesting technique which can be used is that sometimes you really do not need AI, as I said before, because you do not want reasoning. So in those cases, don't use AI or use a less powerful model. For example, for a bunch of classification tasks, you could use a much simpler AI model. You don't need an LLM. Of course, it's easier to do with an LLM, but is it the most efficient? Is it the most reliable? Probably not. It's going to be cheaper to model. In some cases, you can just fall back to business logic. Last but not the least, sometimes, and I say this very, very carefully, sometimes when all else fails, you can also apply various kinds of fine-tuning techniques in order for you to create fine-tuned models. I say when all else fails because people prematurely jump to it without trying all they can do with prompt engineering and RAG and the right systems architecture, right? because it's expensive, since the foundational models keep advancing. As long as you have a fine-tuned model, you have to maintain it. You have to ensure that when your task specification changes, you haven't had loss in generalization, which results in worse performance, etc. So pick your poison carefully, but that is also a technique which is useful in some cases.
Yeah, really great points. I just want to add prompt rewrite is another one that is pretty much baked in now, for example, to our in our search service. So things like that can help a lot.
Thank you. Yeah, definitely, I agree with you all. Like like you all mentioned. So with AI, there's a lot more options available, I guess. So as a developer, as a end user, I would like to have more options that I can pick from rather than fewer options, right? So, but with more options comes more evaluation and more discipline, right? So that's what it is. Okay, yeah, thanks for answering that question also, Karthik, in the chat. Yeah, we can probably to the audience, please go ahead and post any other questions you have. We definitely want to make sure that you are getting any other questions clarified. So regarding the next topic, we can jump into the probably the biggest recent development in this space, the Model Context Protocol (MCP). I know I've been seeing several publications, articles on a daily basis on this. So they claim it's an open protocol that standardizes how applications provide context to LLMs. And they also say that it will help you build agents and complex workflows on top of LLMs, right? So that's the definition on their website. So can you all share, maybe starting with you, Govind, can you share your experience on how you see this MCP as a kind of where it fits in the overall, the evolution of AI solutions, and how can it help? What can we use it for? And where do you see this going? I think it's a
Yeah.
good thing. It's a good standard that we have now, but I know like any standard, it will probably have to evolve, right? So.
Yeah, and actually, let's think about a world without any standards or protocols, right? Like how things are developed actually right now, right? So if you have, let's say, an agentic system, let's pick user onboarding just for the sake of it, right? Let's say you're building like a compound AI system that does user onboarding and hopefully has some agency in some of the workflow tasks there. So let's say, a new employee joins, this orchestration layer, then has to or the developer that is developing this orchestration layer, has to understand, let's say, success factors or ServiceNow APIs, and deterministically kind of code according to those API specs, and also, the day two aspect of that, right? Handle the day two aspect. So if ServiceNow, let's say, changes their interface, this developer has to change this orchestration layer. So if you think about employee onboarding, maybe you first have to create a new employee record in, like, say, success factor, something like that, and then you have to maybe issue a laptop or something like that. That could be a ticket in ServiceNow with all the details, and then maybe even notify the manager or get manager's approval and things like that. So that could be a Teams message or something like that. So you need to know all these API specs and maintain them and all that stuff. Now, what would be nice is if all these systems, and I think going forward, it's becoming clear that we're not just developing systems for humans, but actually for AI agents to consume. If all these systems instead had some kind of standard that they could all conform with, a standard sort of protocol and hopefully a standard transport layer, right? And that's what MCP is basically proposing. Is like, Anthropic started it, and it's fair to say that everyone is embracing it. I mean, let's see how it goes, because the governance layer is still kind of shaky. But for now, at least, everyone is building essentially a simple facade, a proxy on their existing, let's say, SuccessFactors or ServiceNow or GitHub, this MCP server, and the host of MCP. Let's pick VS Code, for example, GitHub Copilot. It could then or this onboarding, agentic system that could then work with these MCP servers, and they have to follow the standard, right? So the client developer now doesn't have to know success factors, idiosyncratic APIs, and like implement them and maintain them. They'll just conform. It's the same MCP standard for all these other systems. And ultimately for, these models, again, they're very great at reasoning, but for them to be economically useful, they have to work with a lot of systems in the real world to actually, for example, this onboarding workflow to be successful, right? It has to integrate with all these systems. And I think going forward, like it's great that we have some standard finally, at least for now. And then of course there's also agent standard that is emerging. There's the new standard I was just reading that is a superset of agent to agent. I think it's called Nanda. So we'll see which one wins out. But it's good that the industry is kind of rallying, and this is nothing new, right? We had in the past. Obviously, we're communicating over HTTP. I mean, that was a standard established by the Internet Foundation or something, right? So there's CNCF. Kubernetes is pretty much the standard orchestration layer now. So I think standards bodies are good. It was just a matter of time, especially a platform shift this big, as I think is bigger than the internet. So, we'll hopefully have more standards for how, obviously this is a standard for agents to talk with resources and tools. Primarily, there's also like prompts and other things there, but there's also hopefully a standard that'll emerge where agents can talk to other agents, have a registry. That's what A2A is trying to do. And then hopefully this other swarm of agents, new standard by MIT, that's also kind of out there. So yeah, there's a lot there, but it's kind of where we are right now. I do think it's an evolving space. So I would love to hear from Karthik again. Yeah.
I think MCP is still an evolving standard. It's a great way in order to connect externally. It still has some gaps, primarily around security, authentication, authorization, which are pretty critical, which is why we haven't deployed it internally yet. But I'm sure it's just a matter of time before the community solves these problems. I think the important thing to note here is that MCP is primarily a protocol for calling tools. It isn't a protocol for agent to agent communication, because agent to agent isn't a synchronous RPC, right? Or even a streaming RPC. It's way more complicated. You have asynchronous handoffs, you have human in the loops, you have multi-interaction patterns, which is why the protocols like A2A and agency and the other emerging ones, I think, will be better fits. Right now, amidst the hype, everyone is trying to force fit MCP everywhere. So I'll just say be thoughtful about where you use it and where you don't.
Yeah, I mean, like, it makes a lot of sense. I think everybody agrees that it has its own place for tool use, and if that becomes a standard, then it opens up a whole slew of make it easy to integrate and use tool use. An example that I came to mind, like something in the past, like we have something called REST, right? So like a protocol for dealing with OHTTP, but this is specifically for LLMs. And yeah, let's see where what's going, but it looks like the industry is it's really there's a lot of explosion of MCP servers out there that I see, and let's see where it goes. But I think it makes a lot of sense.
Cool. Thank you. I do see some questions. Karthik and Govind, you were answering those offline, so that's good. So we are almost out of time. So let's kind of start wrapping up the discussion. Thank you again for the sharing your thoughts and experiences with the audience. So to kind of conclude this webinar, I would like to ask, we kind of put you all on the spot. So let's start with Karthik. Karthik, so what is a prediction that you are, or if you don't want to predict, that's fine. So what's the prediction that you think will happen in next 12 months? So if we were to have a similar discussion 12 months from now, like what do you think we should be excited about? And also if you have any online resources to share, please mention those.
I am feeling like an oracle today, so I will predict one thing. I think that the transformer architecture and LXMs in general will start getting increasingly applied to traditional relevance surfaces like search and recommendation systems, because right now the cost curve as well as the technological advancement is at a point where it is starting to become feasible. And I think we will see a improvement in quality of these surfaces as well, apart from the agentic applications. That's my prediction. Regarding resources, I already put some links in the chat, but feel free to connect with me on LinkedIn if you have more specifics, and I'm happy to share.
Thanks, Karthik. How about you, Govind?
Yeah, I'm gonna kind of, I have this AGI thing up there, but I'll kind of take Satya's approach there, which is if it can be economically useful, and I think his number is $100 billion of economic value, then it's AGI. Because like we see a lot of benchmarks, they're absolutely saturating, but at the end of the day, can it improve human well-being? And that is GDP. And if we can start, whether it's MCP or whatever, start actually giving actuators to these reasoners, right? And then hopefully, again, output per human, the ultimate goal is output per human going up. And once we have that, and we're starting to see that, Cursor was the first product, and I'll say that even as a competitor, to hit 100 million ARR, right? Fastest ever to 100 million recurring revenue. So I do think like that type of, hopefully we'll see it in other domains, not just software engineering, but hopefully in other domains. Then human well-being is actually improving with everything we're doing. So yeah, hopefully that'll happen in the next years. Yeah.
Thank you. And Ian?
This may probably not less of a prediction, but like something I would love to see, especially in enterprise, how AI agents are being applied in the enterprise scenarios. We'd love to see more practical use cases being out there and see how that really works out in the enterprise. I think the part that's exciting is about agent to agents, multi-agent systems, right? There's a lot of discussion about that. It seems pretty fascinating. You get these agents talk to each other and they do their own things. I would love to see how that manifests into real world useful use cases as well. So hopefully we'll see those in the next 12 months. So
Yeah, thanks, Ian. Yeah, I'm kind of the same way. So I think these agents will help us have kind of less thrashing of of lives at work and in personal lives, so we can focus on more important things, whatever they mean, right? To enjoy our
Yeah.
lives and also help the community, right? So we are out of time. So I want to thank all the panelists. Thank you for all your comments and insights in this discussion. And for the audience, thank you for joining us. Before we wrap up, any quick remarks from any of you? Any concluding comments?
I just wanted to add shared prosperity. Whatever it happens, people
Yes.
should not be afraid. There should be a positive sum outcome for everyone.
To quote the Spock, right? So yes. So yeah, thank you all for joining this webinar. We're out of time today. So I do encourage you to check out the infoq.com website for not only this webinar, which will be published shortly, and also other webinars and other podcasts we have on AI and other topics. Thank you all. Have a great one. Thank you.
thank you. Bye.